Okay, we're going to start doing some circuits. So the first thing we got to talk about is the symbols that we're using. There's a couple different symbols. Let's talk about our friend the resistor first. Alright, the resistor has two kinds of symbols that we're going to use in common. Alright, so the first common kind is going to be looking like this. Alright, so there's one, and then the second is like this. So those are your resistors. This one is typically used in the US and this one is typically used in Europe, but you know, they both represent the same idea. Okay? So don't worry if you see one or the other, they're both just resistors. The second thing that we're going to focus on is a battery. Alright? A battery is going to look like this. You should notice one side is big and one side is little. Alright? The big side is the positive terminal of the battery. The little side is the negative terminal. So that means that electrons are going to flow this way out of the battery. Alright? Because electrons leave the negative, because it's the same charge as them, and they run towards the positive. Alright? The last kind of symbol that we're going to see is a light bulb. Alright? So your light bulb, there's a couple different symbols. We're going to just use the one that looks like this, because it's easy to draw. Ta-da! So there's a light bulb, you can kind of tell it's a filament. Some other symbols just so that we can have it. Some people put an X like there. Some other symbols that they've seen is something like that. Whoops. Yeah, that's the right one. Oh, and that reminds me, there's one more, something like this. All of those I've seen used for light bulbs. I'm going to stick with this first one. What you should be aware of is this one is less official. Also because there's different types of light bulbs. There's incandescent, LEDs, fluorescent, all that jazz. So they do have different symbols to represent different kinds. We're just going to stick with the first one and apply it for everything. I think it's incandescent for the first one, but it's good enough for us. All right? And just so you know, the lines here, these are just wires. So the wire, you know, there's just connections between things. So you can have like a battery and a resistor, you know, connected to something else. Something like that. Awesome. So we're going to talk about what a series circuit is. There's two kinds, and this is the first kind of circuit. So a series circuit is when everything is connected. Well, no, duh, Mr. Well, yeah. Everything is connected in one path. Alright? So, for example, here's my battery. Here's my resistor. Here's a light bulb. Here's another resistor. Here's another light bulb. Oops, a less pretty light bulb. Whatever. So this, I'm going to finish it off here, close the circuit. So this is a series circuit. Alright? So a series circuit has everything in one path. You should notice that if I were an electron, I would go through this resistor, and then I would go through this light bulb, and then I'd go through the other resistor, and then I'd go through the other light bulb, and then I'd go wee, all the way home to the battery again. Alright? So you have to go through everything in a series circuit. Okay? There is no escape. Let's talk about the other kind. The other kind is a parallel circuit. So fun. So a parallel circuit is when there are branching pathways. So let's draw an example here. Here's a battery. Here's a resistor. Here is a light bulb. Here's another resistor. And then these all go wee, 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 all the way home. Okay, so here's a parallel circuit. Alright, we know it's parallel because there's branching pathways. Let's pretend we're an electron again. If I were an electron, well, I'd be pushed away from the battery, and then I'd have a choice. I could go through this resistor, or I could turn that way. Let's say I go through this resistor. Whee! And then I'd be pushed over to here. Nice. I'm going to follow the other path now. I'm going to show up here. I could be pushed either towards the light bulb, or I could be pushed that way. Let's pretend I go through the light bulb. Whee! And I'm going to arrive there. Let's pretend I didn't go through the light bulb. I'm going to go this way, around, through the resistor. Whee! And back up to here. Now, once I arrive at this spot, I can't go downwards because that's up the river. You know, there's electrons pushing me forwards. You can't turn left, so the current is going to be going this way. Once I get to here, you can't go up or down because that's not the way the current is going. Well, sorry, that's not the way the electrons are going. So you'd have to go this way. And then you go wee, 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 all the way home to the battery. Now, what you should notice here is each electron will not go through everything. Electron will only go through one device, other than the battery, of course. Okay? So if you go through the first resistor, then you're done and you get to go back to the battery. If you go through the light bulb, you don't go through anything else. You get to go through the battery, and so on and so forth. Okay? So that's what makes parallel different than a series. Now, we can combine them together, but who wants to do that right now? We do need to talk a little bit about current. Okay, so there are, get this, two types of current. So there is something called conventional current. And then there is something called real current. Let's talk about real current first. Real current is the flow of electrons. Alright, so real current, let's pretend we have a battery like this. And some resistor. Nice, easy circuit. So, which way is the real current going to be going? Well, the electrons leave the negative terminal, right? So negative to positive. So they leave the negative terminal and they're going to go towards the positive terminal. So the current is going to be going like this. This would be the real current. Now, the conventional current is the flow of positive charge. Alright, since it's the flow of positive charge, this is against electrons. Oops. Because remember, electrons are negative charge. So if electrons are flowing one way, that's the same thing as having positive charge flow the other way. So the conventional current is going to go the opposite direction. Doesn't that sound fun? All right. So now I know what your question is. Well, how do you know? Well, you know because you're always going to use conventional current. But Mr. Keeney, that's stupid. Yes. So we are always going to use conventional current unless you're in a very, very specific scenario, and you're not going to come across that in this class. So you're always going to use conventional current. Why is conventional current dumb? Well, because conventional current, the basics for electricity, were made by Mr. 100 himself, Ben Franklin, where he saw that there was a current traveling, and he basically just guessed which one was positive and which one was negative, and he said the current's going to go from positive to negative. Now, remember, Ben Franklin was around in the 1800s, huh? And electrons weren't discovered until around 1912 by Mr. J.J. Thomson himself. So this was in operation for over 100 years before the electron was isolated, and it was known that electrons were causing the current. So that is why we still use conventional current. It is Ben Franklin's fault.